Good morning, geometry. We're going to continue our talk with similar figures today. So remember that similar polygons have two things, right? Their side lengths are proportional and their angles are congruent. I'm just going to put our little congruency sign here. So two things about similar polygons: side lengths are proportional, meaning equal ratios, equal fractions, right? And then angles are congruent. So similar triangles can be used in indirect measurement. And what does indirect measurement mean? Indirect measurement means that I can find the measure of things based on the measurement of other things. So we can build proportions based on measurements that we know, and then compare them to measurements that we don't know, like things that are very large or things that are very small. If they're proportional, if they're similar, then we can use proportions to solve for those things. So let's look at this for an example here. This one is a little bit tricky because we have two triangles, and what I like to do with these is I like to take these triangles apart so I can see them better together, separately. All right, so we have right angles here, and I know that these are similar, so this value is 10, this value is 5, this value is 22, and this value is x. So remember, we're looking for corresponding parts, and so when I can build a proportion based on my corresponding parts, then I can solve for that missing value. So this is what indirect measurement looks like. Still using proportions, still using cross multiplication, just like we have been. So I can build it this way: 10 to 22, that's my corresponding side lengths, and 5 to x, that's my corresponding side lengths. So know on the top that I used the small triangle, and on the bottom I used the larger triangle. There are other ways to build the proportion, but today we'll just do it this way: small on top, large on bottom, and then we'll do it that way. So let's go ahead and cross multiply. So I have 10 times x equals 22 times 5. I already have my calculator here, and it's 110, and then divide, and x equals 11. And that's all we're doing, because all we're doing is solving for x. So best way to do it is to pull those triangles apart and solve that way. So let's look at this one. Find the value of x. Again, I have a smaller triangle inside of another triangle. So I am going to pull them apart and see what they look like. So here's my small triangle here, 8 and 3. And here's my larger triangle here. X is this value here, and 6 is this value here. So I'm going to do the same thing. I'm going to do small triangle numbers on top and larger triangle numbers on the bottom. So small triangle is 8 divided by x equals small triangle on top, 3 divided by 6. Go ahead and cross multiply there. 8 times 6 is 48, and 3 times x is 3x. Divide next, see our pattern here that we're following, and x equals 48 divided by 3. You probably already knew that, and it was 16. And we're just solving for x there, so we didn't have to take it and plug it back in. All right, here's another one, same kind of thing. We have a tree, right? We know the height of the tree, and we're going to find the height of this building, this very large figure here, based on probably the shadow that we have here. So I'm going to still draw out my triangles just like we did before. Oh, I didn't give myself enough room, that's okay. So my tree shadow is 24 meters, and my tree height is 21 meters. My building shadow is 56 meters, and my building height is x. We don't know that value yet. So let's go ahead and do small to large. We'll do the same thing, that way we can keep it consistent. So I have 24 to 56, and then my next fraction is 21 to x there. So we'll cross multiply, and we have 24x equals I don't know that number. 56 times 21. A large number. 1,176 divided by 24. And we get 49. Oh, that's a nice even number. Not even. That's a nice whole number. 49. And then if I plug it back in, because notice I have some units here, my building is 49 meters if we want to be very specific about it, all right? So that's how we can use proportions, equal ratios to solve for indirect measurement. So let's look at these that don't have pictures with them, and we'll draw the pictures on here. When Stephanie stands 2 feet from a lamppost, her shadow is 3 feet long. If Stephanie is 5 feet tall, how tall is the lamppost? All right, so let's see. 2 feet from a lamppost, her shadow is 3 feet long. So let's see if, here's our lamppost here. I feel like I don't have enough information, but let's see. So, oh, she is 5 feet tall, okay. So she's 2 feet here, right? 2 feet here, and her shadow, draw like a thing here. Her shadow is 3 feet long, and she's 5 feet tall. And we want to know how tall is the lamppost. Put a little smiley face on Stephanie there. All right, so let's first draw out our triangle. We have the small triangle, that's Stephanie's height, and the larger triangle, that's the lamppost. A little bit different here. Stephanie, we have 3 and 5. And look here, I don't know this whole length, but I do know that she's standing 2 feet away from the lamppost. So I do know that this altogether is 5. So I can go ahead and deduce that. And we want to see how tall is the lamppost. So we'll do again, small as numerator, large triangle as the denominator. We'll do 3 and 5 and 5 and x. The way that you set up your proportion is the most important, because if you don't set it up correctly, then you won't get the correct answer. All right, let's cross multiply. We get 3x equals 25. Divide 25 divided by 3, and we get 8.3 repeating. We'll just put a little bar above that saying it's repeating. And that's how tall our lamppost is, 8.3 feet. Seems pretty short, huh? All right, let's do example number 5. Charlie walks away from a tree along its shadow until his head is in line with the top of the tree's shadow. Charlie is standing 15 feet from the base of the tree and 6 feet from the end of the shadow. Charlie is 5 feet tall. What is the height of the tree? So we have this tree, right? Weird looking tree. And here's Charlie. So thinking about the top of the shadow, kind of looks like this. Have you ever like tried to be in the shade of a tree or a lamppost or a building or something, and you have to get like right where the shadow, if you're too far forward, then your head's in the sun. That's what he means here. So he's right here where the top of the shadow is on his head like that. And he's smiling too. All right, so Charlie is 15 feet from the base of the tree. So here's from the base of the tree here, right? 15 feet. And he's 6 feet from the end of the shadow. So we'll say the end of the shadow is right there. And he's 6 feet from that. Charlie is 5 feet tall. We got some shorties here, just like me. And we want to know how tall is the tree. So it's kind of looks like the last one that we did. So let's draw our 2 triangles. We have a smaller triangle, that's Charlie's triangle. And then there's the tree's triangle. So Charlie is 6 and 5. And we have to do this whole thing here, 6 and 15, that's 21. And we want to know how big or how tall is the tree. So let's build our proportion. We'll do small, large, same that we've been doing. 6, 21, and then 5 and x. We'll cross multiply here. We get 6x equals 21 times, move it over here so you can see, times 5. And that's 105 divided by 6. So it looks like the tree is 17.5 feet tall. Not too bad. That's a pretty big tree. All right, so we're going to do example 6 in class together. And I want to look really quickly at this discussion board. Question: Mario is 12 feet in the air standing on a brick. If he jumps down 24 feet, he will land on the green pipe, which is 4 feet tall. Mario thinks he can bounce off the green pipe to reach the gold star, which is hovering 16 feet above the ground. The longest jump Mario has ever made is 40 feet. Will Mario be able to jump high enough to reach the gold star? So we want to know, you can use your hints here, that's totally fine, but it won't tell you the answer. So it'll tell you exactly, can he make this jump here, this X? And remember, it's 40 feet. So if it's longer than 40 feet, then you probably can't make it. But if it's less than 40 feet, then you probably can make it. So use these measurements here, right, to find that X value. And then we'll also do this in class together. All right, so I will see you soon.